Alright, so let's start by classifying the individual spheres as divisions of the viewport. This first one is the center sphere. You might think of it as the radix of a solar system or the nucleus of an atom. Notice that for each sphere we have a root class and a particular instance of that class. Next, let's go ahead and write their specifications. So when the program calls the sphere and foci functions, it's instructing WebKit to render the elements with position absolute. We're going to pass the width and height as size variables, and we're going to initially center each element by placing it at 50% the height of the viewport minus the element's size divided by 2. And I actually do have a parenthesizing error here on line 25. I'll fix that in a second. But let's run the same calculation for the horizontal placement of each element. And then we'll give each element a border radius of 50%, so as to give each element its globular form. And this z-index minus 1 is arranging the system relative to the title element, which floats in the forefront of the viewport. Alright, so the solid sphere, our radix, will give a size of 100 pixels, and we'll attribute to the background a radial gradient, and let's attribute an animation timing to Solace of 1 second, and an animation type of infinite linear. Okay, let's initialize the remaining spheres in a similar manner. We'll give sphere 1 a size of 20 pixels, sphere 2 a size of 25 pixels, sphere 3 a size of 40 pixels, sphere 4 a size of 30 pixels, sphere 5 a size of 70 pixels, and sphere 6 a size of 40 pixels, sphere 7 a size of 50 pixels, and sphere 8 a size of 30 pixels. Sphere 1 gets an animation timing of 1.5 seconds, and again, choose whatever color range you prefer. Sphere 2 gets an animation timing of 2 seconds. Sphere 3, animation timing 2.5 seconds. Sphere 4 gets an animation timing of 3 seconds. Sphere 5, 3.5 seconds. Sphere 6, 4 seconds. And as a sort of auxiliary exercise, suppose we were modeling a solar system, or our solar system. This would be a simple way to model the rings of Saturn. So we would initialize a secondary sphere 6 element with a content of empty, a position of absolute, again 50% vertically and 50% horizontally, and a width slightly broader than that of its parent sphere. We want the rings to sort of extend just beyond the planet itself. And we'll give the rings a height of 10 pixels, with a border of 2 pixels solid white. Let's eliminate the border top, and give the element a border radius of 50%. And then we just need to transpose the element, 50% on the x-axis, 50% on the y-axis, and we'll rotate it at 30 degrees. Perfect. Alright, continuing on with the animation of the spheres, we'll set sphere 7 at 4.5 seconds, and sphere 8 at 5 seconds. Alright, let me just quickly correct the parenthesizing of the numerator on line 25. Great. So let's set up the keyframes. Now, the keyframes control the intermediate steps in a CSS animation sequence. So this gives us a bit more control over the intermediate steps of the animation. So let's see how that's done. So this function setup dictates the orbital path of a given sphere. Let's go ahead and initialize them for the complete set. Each begins at 0 degrees. And follows a 360-degree precession, frame by frame. Alright, so let's send our first sphere into orbit, and let's translate it along the x-axis by 80 pixels. Alright, let's send sphere 2 into orbit, with a translation along the x-axis of 120 pixels. Sphere 3 at 160 pixels. Sphere 4 at 200 pixels. Sphere 6 at 260 pixels. Sphere 7 at 360 pixels. Sphere 8 at 400 pixels. And let me actually go ahead and make this correction. I did notice that initially I had omitted sphere 5, so let me go ahead and include sphere 5. Translate it to 260 pixels. Let's update sphere 6 to 320 pixels. And the rest should be fine. And then finally, for 𝗕cie, our radix, or nucleus, we can actually eliminate the translate attribute, as we're going to have it simply spinning or rotating on its own axis. All right, and there you have it. That is the complete program. Now let's go ahead and expand the viewport so that we can see a greater amount of the system dynamics at play here. Excellent. All right, and so just another thing to maybe mention quickly is that if you hit Command S, or by hitting Command Enter, we can reset all of the spheres to their initial position and resend them into orbit. That way we get to see the sort of familiar shell spiral or Fibonacci spiral or whatever you might call it. All right, great. So there you have it. So if you have any questions, feel free to comment below or shoot me a message. And until then, I'll see you in the next one.